All right, folks, it's Mr. Ryan, and in this video, I am going to show you how to solve a system of equations, linear equations. I'm going to show you how to solve a system of linear equations using a technique called elimination. Now, in order to understand how to solve a system of elimination or a system of equations using elimination, it can be helpful. You don't have to know it, but it can be helpful to know what is called the standard form of a line. Now, recently you probably learned or you reviewed that two of the forms that you can write a line are called slope-intercept form, which is y equals mx plus b, and then there's my preferred form, point slope form of a line, which is y minus y1 equals m times x minus x1. You may also see it as y minus k is equal to m times x minus h. So basically the idea is, if you recall the x1 and the y1 and the x1, that's a coordinate, an xy coordinate, and then just like the coordinate hk, that's a coordinate, okay? So we've got the slope-intercept form, the point-slope form. And here's what I'm telling you is that there's even a third form of a line, which is called the standard form of a line, okay? And I'm going to show you that right now. So the standard form of a line goes like this. ax plus by equals c. And in this particular case, the x and the y are variables, and the capital A, is a coefficient for x, capital B is a coefficient for y, and c is the constant, and it is put on the other side of the equal sign. So I can show you an example of, let's say that we have a line in slope-intercept form. Let's say that we have y is equal to negative 4/7 x plus 2. We've got a slope of negative 4/7, and we have a y-intercept of 2. So to turn this into the standard form of a line, what we want to do is we want to put this, we already have the y term on the left side of the equal sign. See, we got on the left side of the equal sign is the x and the y term, and then on the right side of the equal sign we have the constant. Okay, well the constant is already on the right side of the equal sign, and the y term is already on the left side of the equal sign, but the x term has to be moved from the right side over to the left side. On top of that, in the standard form of a line, we don't want a or b or c to be a fraction. We want them to be whole numbers if possible, okay? It's easier to understand or use or manipulate if it's not a fraction, if it's a whole number or an integer in those three places. So here's what I want to do. Before I move this x over, do you see this fraction 4/7? I want to get rid of the fraction. And the way I get rid of the fraction is going to multiply through by the denominator. I'm going to multiply everything by 7. So 7 times y is 7y equals 7 times negative 4/7. That's going to cancel the denominator and bring down the negative 4x. 7 times 2, that's 14. Now I can move the x over to the left side of the equation. So if I add 4x to both sides, here's what I get. I get 4x positive 7y, so that's plus 7y is equal to, bring down the 14, and this is now my standard form of the line. 4x plus 7y is equal to 14. See, our a is 4, our b is 7, and our c is 14. Okay, let's do one more example of the standard form of a line. Let's say that it's not slope-intercept form. Let's say that it's just in some weird order. Let's say that we had 16. Let's say. Let's say we have 16 minus 3x is equal to 2/3 y. Okay? And so we've got a fraction here. We don't have it in, we got to put the y over on the left side. We got to put this constant over on the right side. Well, to get rid of this fraction, we'll multiply through by 3 by the denominator. Let's multiply everything by 3. So 3 times 16, that's 48. 3 times negative 3x is negative 9x. 3 times the 2/3 y is going to cancel the denominator, bring down the equal sign, bring down the 2 and the y. Okay? So now we don't have a fraction anymore, but it's still not in the correct order. We got to put this y over on the left side, and we got to put this 48 over on the right side. So we're going to subtract 48 from both sides. I'll cancel over here. We got negative 9x is equal to 2y minus 48. And then we're going to subtract 2y from both sides. Subtract 2y. That's going to cancel over here, and we're going to have negative 9x minus 2y is equal to negative 48. Now here's the weird thing. Look at this. We got a lot of negatives in here. Now usually with this standard form of a line, we would prefer to not start off with a negative, or the other option is not have a negative over here on the right side. So here's what I'm going to do. I'm going to actually multiply through by negative 1. Negative 1 times negative 9 is positive 9x. Negative 1 times negative 2y is positive 2y, and then that's equal to negative 1 times negative 48 is 48. And we can accomplish the same thing if I just simply add 48 to both sides, add 9x, and add 2y to both sides, and what it'll do is it'll move this over to this side and this over to this side, and it'll equal this. But this is still the same thing as that. They're just moved to the other side, okay? And this is now the standard form of a line. And now that you know how to write the equation of a line in standard form, what we're going to do now is I'm going to show you how to do what's called the systems of equations, how to solve by elimination, okay? And so I'm going to put some steps up on the board, and then we're going to do some examples. All right, folks, so what I've done here is I have put a step-by-step procedure on how to solve a system of equations by elimination. What we'll do is we will read through these steps to solve this system of equations. So you may want to write this down and then write these down, and we'll go through the steps. Step 1 says to rearrange both of the equations into standard form and then stack them vertically. Well, they're already stacked vertically, but they're not in standard form, so we're probably going to have to rearrange them and then restack them vertically. I'm going to go over here to the side here. So I'm going to put 7y is equal to 11x plus 13. Well, this one's easy to put in standard form. All I have to do is subtract 11x from both sides. Although when I subtract 11x from this side, I don't want to write 7y minus 11x. Instead, I want to write negative 11x, and then this is a positive 7y is equal to positive 13. So this is now in standard form. Okay? And I know what you're thinking. Didn't you say you want to have like a positive up here? Well, I'm happy that the constant over here is positive. So because the constant is positive, I'm going to go ahead and leave the x as negative because my 7y is also positive. So I'll leave it like that. Now, this one right here, we got 11x equals 5y minus 3. I got the 11x on the left side. I just need to put the 5y on the left side. So I'll subtract 5y here and subtract 5y here. That's going to cancel here. It's going to give me 11x minus 5y is equal to negative 3. So now I'm going to bring them over here and stack them vertically, put one on top of the other. So I got negative 11x plus 7y is equal to 13. And now I'm going to put the exact same variables, each part right underneath. I'll have the equal sign here. I'll put the minus 3 here. And then I have 11x and then minus 5y right here. Okay, so they are stacked vertically. I have the x's on top of each other, the y's on top of each other, the equal signs on top of each other, and the constants on top of each other. That's what I mean by stack them vertically. Once it's like this, you can move on to step 2, and sometimes you can skip step 2 and then go straight to step 3. Okay, Step 2 says multiply one or more factors through one or both equations. Okay, what that means is this, is, if I have like 7x minus 3y is equal to 11. I can change this equation by multiplying by a number. Let's say I multiplied through the whole thing by 5. If I did 5 times this whole thing, 5 times 7x is 35x. 5 times negative 3y is negative 15y equals, and then 5 times 11 is 55. And here's what I'm saying is that this equation of the line is the same as this equation of the line. This line and this line they're the same line because it's really just the same line multiplied through by 5. Okay? And so that's what I mean by multiply one or more factors through one or both equations. And what I'm saying is sometimes you may only want to change one of the equations, not both of them. But sometimes you have to change both of the equations so that you can eliminate one of the variables. And that's what we're trying to do. We're trying to eliminate one of the variables. Now let's read the rest of this. You're multiplying one or more factors through one or both equations so that one variable, meaning x or y, it doesn't matter which one, as long as one of them has the same coefficient in both of the equations, except that one of those coefficients is negative. So if I look at this, I want to have the same number in front of both of the x's or the same number in front of both of the y's. Now y has a 7 in front of it here and a negative 5 in front of it here, so I would have to change one of those or change both of them. But I don't need to, because if you go over here, look, the x has an 11 in front of it in both of them. I already have this. I already have the same coefficient in both equations. And look, one of them is already negative and one of them is not negative. Now, if this was not negative, let's say that this was positive 11 and this was negative 7 and this was negative 13. What I could do here is I could multiply by negative 1 to make sure that this one of these becomes negative. I could also do it down here instead, but I'm going to do it up here. So negative 1 times 11x is negative 11x. Negative 1 times negative 7y is plus 7y. And negative 1 times negative 13 is positive 13. And so now it would be ready to eliminate. But that's not what had happened. The way we did it in such a way that we made sure that the 11 was already negative. So we didn't have to change it at all. This was already negative, this was already positive, this was already positive. And so from here, we can move on to step 3. Vertically add the two equations. So I'm going to draw a line under here, and I'm going to add, right? Negative 11x plus 11x is 0. And what that's going to do is that's going to eliminate the x's completely. In fact, that's the point. Look, this should cancel or eliminate one of the variables. And now 7y minus 5y, well, plus negative 5y, 7y minus 5y is 2y. And then 13 minus 3 is 10. Okay, so we did that. And then step 4 says, vertically add the two. This should cancel. Oh, I forgot to put on here. It should cancel one of the variables. Oh, yeah, it says step 4, solve for the remaining variable. So this is the remaining variable. There's only a y left. So we can solve for it. Divide by 2, and we get y is equal to 5. So that's half of our solution. In a system of equations, we're trying to get a value for both x and y. We don't just want one solution. We don't just want to know what y is equal to. We want to know what x and y are both equal to at the same time. So y is equal to 5. Now to find out what x is equal to, step 5 says plug the solution from step 4 into one of the original equations and solve for the other variable. So I'm going to go up here and I'm going to take maybe this one right here. See this 11x is equal to 5y minus 3? I'm going to put the y, the 5 in for y right here. So over on the side, I'm going to do 11x is equal to 5 times 5. I'm replacing the y with the 5 because y is equal to 5. So this is 5 times 5 minus 3. So I've got 11x equals 5 times 5 is 25 minus 3, and 25 minus 3, 11x equals 25 minus 3 is 22. Now I'll divide by 11, and I get x is equal to 2. And so my solution is x equals 2 and y equals 5. Let's do another example. All right, here's another example, another system of equations, and we're going to solve this one by elimination. So what we want to do is put both the top and the bottom equation into standard form, okay? Well, this 3 is going to have to go over to the other side. Let's see, let's do 3 plus 6y equals 5x. And I'm going to subtract 3 from both sides. So I get 6y equals 5x minus 3. Then I'm going to subtract 5x from both sides. 5x, cancel here, and I get negative 5x, positive 6y equals negative 3. Okay? I don't like this negative and I don't like this negative, but for now I'm going to leave it alone. I'm just going to leave it as is and see what happens on this other one. For this other one right here, see I got 7x equals 33 minus 6y. All I have to do here is move the 6y over to the left side. So I'm going to add 6y here, add 6y here, and I get 7x plus 6y is equal to 33. There we go. So this is one of my equations. This is my other equation. And so what I'm going to do is I'm going to stack them vertically on top of each other. I'll put this one first. So I got negative 5x plus 6y equals negative 3. And I'll take this one, 7x plus 6y is equal to 33. And now, step 2 says I need one of the variables to have the same number in front of it. Well, look, I do. Y has a 6 in front of it, and this y also has a 6 in front of it. Now the x, one of them has a 5 and one of them has a 7, so I don't want to mess with that right now. Let's go to the one that already has the same number in front of it, okay? The problem is that step 2 says that except that one of them is negative, and here this one's positive and this one's also positive. So I need one of them to be negative. So here's what I'm going to do. I'm going to take this first equation and I'm going to multiply through by negative 1. By multiplying by negative 1, that'll make this positive 6 negative 6. Negative 1 times negative 5x is positive 5x. Negative 1 times 6y, positive 6y is negative 6y equals, and then negative 1 times negative 3, that's positive 3. Now, I have fulfilled the condition of step 2. I have the same number in front of one of the variables, and one of them is positive and one of them is negative. Now I'm going to draw my horizontal line and I'm going to combine vertically. I'm going to combine like terms vertically. I can combine 7x and 5x. If I add those together, I get 12x. Now, 6y minus 6y, if I combine those, that becomes 0. That is eliminated. That's what we mean by elimination. That's why we call it elimination. So then equals 33 plus 3 is 36. And now the next step, step 4, solve for the variable. Divide by 12 on both sides, and we get x is equal to 3. Now, we're going to take this x equals 3 and go to one of our starting equations. Let's go up to the first equation here. So we'll do 3 plus 6y equals 5 times x, and x is 3, so we'll do 5 times 3. So we have 3 plus 6y is equal to 5 times 3 is 15. Then we'll subtract 3 from both sides, cancel, and we have 6y is equal to 12. Then divide by 6 on both sides, and we get y is equal to 2. And we have our solution. X is equal to 3, and y is equal to 2. All right, here's another system of equations that we can try elimination on. Why don't you, right now, pause the video and you try to do this one on your own. Okay, so now let's see how well you did. Okay, I need to put this in standard form. So watch what I'm going to do here. I'm just going to add 8y to both sides. If I add 8y and add 8y, that'll cancel over here, right? And then that'll bring my 8y over here. So one of them is 5x plus 8y is equal to 7. This one, I just need to move the 15x over to the other side. So I'll subtract 15x here, and I'll subtract 15x here. That'll cancel this. And then I'll have negative 15x plus 2y is equal to negative 8. Okay? Now, in this case, I do not have the same number in front of y, and I do not have the same number in front of x. But watch what I can do. I can multiply one of these two equations by a number and then make the number the same in front of one of the variables. Okay? So see how there's a 15 here with the x? It says negative 15x. What I would need in front of this x is a positive 15, but I don't have a positive 15. I have a positive 5. But if I multiply this by positive 3, if I multiply through the whole thing by positive 3, it'll make that number a positive 15x. So I could, one possibility is I can multiply through the top times positive 3. Then I'll have 15x here and negative 15x here, and I can eliminate. The other alternative, if I look at the y's here, I have a positive 8 in front of the y, and I have a positive 2 in front of this y, right? What I would like to have down here, usually you change the one that has the smaller number, right? I'm not going to change this negative 15. I'm going to change the 5 because the 5 is smaller and it can be multiplied up to be the same as this number, right? Well, technically this is smaller because it's negative, but I mean the magnitude is larger. Here, I don't want to change the 8 to go down to a 2. I want to change the 2 to go up to an 8. What can I multiply the 2 by to turn it into an 8? I can multiply it by 4. But the problem with multiplying by 4 is that it'll become positive 8y. Then I'll have a plus 8y here and a plus 8y here. I do not want two of the same sign. I need, except that one is negative. I need one of them to be positive 8 and the other one to be negative 8. So in order to turn this positive 2y into a negative 8, I'm not going to multiply by 4, I'm going to multiply by negative 4. When I multiply by negative 4 times positive 2 is negative 8, and then I'll have what I need. So I think I'm going to go with the 8. I'm going to multiply this thing right here by negative 4. And so it's going to become negative 4 times negative 15. If you have to do that in a calculator, that's fine. But this is going to be, it's a negative times a negative, that's a positive, and 4 times 15, that's 60. So I'm going to have 60x. Negative 4 times positive 2 is negative 8y. Bring down the equal sign. And negative 4 times negative 8, negative times a negative is a positive, so 4 times 8 is 32. Now, I don't have to change the top one because I already have a negative 8 here and a positive 8 here. So all I'm going to do with this equation is carry it down. Bring down the 5x, bring down the plus 8y, equals, bring down the 7, and now I'm going to combine vertically. Negative 8y, positive 8y, that's going to eliminate. 60x plus 5x is 65x, equals 32 plus 7 is 39. Uh-oh, it's a little crazy. Now I'm going to divide by 65 on both sides, and I get x is equal to, this is crazy, 39 divided by 65. Well, oh, hang on a second. I can reduce this. There is a number that divides into 39 and 65, and that number is 13. 39 divided by 13 is 3, and 65 divided by 13 is 5. And so x is equal to 3/5. So that's my first solution. X is equal to 3/5. Now, what I want to do is I'm going to go back up and take one of my original equations, which is 5x equals 7 minus 8y. So 5x equals 7 minus 8y. And I'm going to plug 3/5 in for x. So I'm going to have 5 times 3/5 is equal to 7 minus 8y. Now here, 5 times 3/5 is 5 times 3 is 15 divided by 5 is 3. Or I can just cancel the denominator. Bring down the 3 is equal to 7 minus 8y. Now I'm going to subtract 7 from both sides. And I get 3 minus, this cancels. 3 minus 7 is negative 4 equals negative 8y. Now I'm going to divide both sides by negative 8. And I get y is equal to negative 4 over negative 8. Well, a negative divided by a negative, that's a positive. So it's positive 4/8. And 4/8 can be reduced to 1/2. And so what I really have is x is 3/5 and y is 1/2. That is my solution for this system. Okay? Let's do one more example of elimination. All right, here's a system of equations. If you want to try, go ahead and pause the video and solve this by elimination. All right, let's see how you did. I want to move this negative 3y over to this side, so I'm going to add 3y to both sides. Add 3y, cancel, add 3y. Then I'm going to subtract 8 here and subtract 8 here, cancel on this side. And I have 2x plus 3y is equal to negative 8. Okay? Now this second one here, I've already got the 7y on this side. I want to move this 5x over here. So I'm going to subtract 5x from both sides. It's going to cancel this. Then I want to subtract 38 from both sides. That's going to cancel this. And now I have negative 5x plus 7y is equal to negative 38. Okay? Now, here I have a problem. I need the same number in front of both of the x's, or I need the same number in front of both of the y's. X has a 2 in front of it here, and it has a negative 5 in front of it here. And there is nothing that I can multiply by the 2 to make it a 5. Well, I could do it with a fraction, but that could become really problematic. I want to leave these in integers, okay? Also here with the y, this y has a 3 in front of it, and this y has a 7 in front of it. And there's nothing I can multiply the 3 by to make it a 7. When that happens, here's what I have to do. I have to change both of the equations and turn both of the coefficients of one of the variables into one number. Okay? So for example, and typically the easiest way to do that is to just simply multiply this equation by that coefficient and then multiply that equation by this coefficient. Here's what I mean. If I multiply this whole equation by 5, that'll make this a 10. Then if I multiply this equation by 2, that'll make this a negative 10. Then I'll have the same number, but one of them is positive and one of them is negative. So I'm going to multiply this. It takes a little bit of problem solving. You got to think this through to figure out the right numbers. And I'm going to multiply by 5 here. And then on this equation, I'm going to multiply by 2 here. 5 times 2x is 10x. 5 times positive 3y is positive 15y equals 5 times negative 8 is negative 40. Down here, 2 times negative 5x, that's negative 10x. 2 times positive 7y is positive 14y equals, and 2 times negative 38, that's negative 76. You might need a calculator for that, but maybe not. Now, I have the same number in front of one of the variables, in front of x. One of them is positive, one of them is negative. So now I can add. And 10x minus 10x cancels. That eliminates. My x's are now gone. 15y plus 14y, well, that's 29y. And that equals negative 40 and negative 76. You know what? I'm going to get a calculator for that one. Let's see here. That's negative 116. Now I'm going to divide by 29 on both sides. Let's see if 29 divides into that. It does, 4. So now y is equal to negative 116 divided by 29 is negative 4. So I have my solution for y, and now I want to get my solution for x, so I'm going to plug negative 4 into one of these two equations. I'll use the first one right here. 8 plus 2 times x equals negative 3y. So this negative 4, which is y, I'm going to put it in for y here. So I'm going to have 8 plus 2x is equal to negative 3 times negative 4. So now I have 8 plus 2x is equal, negative 3 times negative 4 is positive 12. I'll subtract 8 from both sides, and I'll get 2x is equal to 4, divide by 2, and x is equal to, what? 4 divided by 2 is 2. So my solution is y is negative 4, and as x is equal to 2. And that is solving systems of equations by elimination.